As we have finished the DC analysis of MOSFET, including Q point computations, load line estimation, small signal modeling, and understood the behavior when we injected an AC signal. Now we are at the stage to provide you the different configuration of MOSFET by which we can design amplifiers. Why we said discrete circuit amplifier? Because we are now attaching the discrete components, resistors, capacitors, and other things to design an amplifier. Its counterpart is the IC based amplifier, in which everything is fabricated on a wafer, right? So let's start with, as we did in the BJTs. I'm not going to tell you how many configuration are there. They are the same. Common source amplifier, common source with source resistance, common gate amplifier, common drain amplifier, right? All are same. So we are starting with directly to the common source amplifier. It means it would not be having a source resistance. So it means even if we have a resistor here, it is bypassed for AC signal, right? So here for amplifier, you already know the DC analysis, right? How to do the DC analysis. So here directly we are going to the AC equivalent circuit, right? So this would be grounded. This is already bypassed, so it doesn't matter. So, and this capacitor would be short circuited, this one and this one, right? This is grounded. Showed only to tell you that it was the biasing power supply. Otherwise, it is now zero, right? So signal is applied, AC signal is applied at the gate with respect to the source, and output is going to be taken at the drain with respect to the source, right? So it's a common source amplifier, right? And because there is no source resistance, it is better to use pi model, right? So here they showed you the AC equivalent circuit by shortening the capacitors, and even though they are already put 0 volt here to show the AC circuit, but they excessively drawn another one, right, to tell you that you can see your input resistance would be input resistance of the stage for this signal would be looking at the gate, right? So now we can replace this with its pi model. By replacing this with its pi model, the gate, the drain, the source, the gate, the drain, the source, right? And because we are considering the early effect, we have the resistance output here, right? Here you can see they already put a resistor here even without replacing it with this model, just to show that we can also do the AC analysis directly on the circuit instead of drawing the equivalent circuit, right? But here you should be having more experience, right? Because it's not easy to see which resistor is coming to which parallel with which resistance and which is the input and which is out. But here you can see everything is streamlined, right? So once you have replaced the transistor with its pi model, now attach the other things. Source is grounded, source is grounded. You would be having a drain to source resistance to cope up with, or to consider the, or to model the early effect. Okay, and then you have a drain, there is a RD grounded, and there is a load resistance which is grounded as well, right? At the gate we have RG grounded, R signal, and this, right? And here this is insulation, right? You have to be more expert if you are analyzing your circuit here, but here you can see easily that you have an infinite resistance here, right? But this RG, because it is coming in parallel with this one, right? So in fact this model is working very fine, not having any resistance, infinite resistance, but the signal which this port is going to taken from this signal is being divided between this and between the parallel combination of this, right? So, and this is the one which is decreasing this infinite resistance, right? So Rn is Rg parallel to infinite resistance, and it is actually Rg, right? So it means V in will be appearing across this one. Okay, so V in relation would be equal to V in is equal to Rg divided by Rg plus R signal into V signal. Remember, so this is the V in, right? How about V out? Because this V in is nothing but VGS. It's the same, right? So you can say VGS is equal to V in, which is equal to Rg divided by Rg plus R signal into V signal. So once you have found VGS, now GM VGS is the current passing through here, right? So what would be your output? Your output would be equal to minus, because this terminal is the leaving terminal, right? So these three resistances are actually taking this current from the ground reference and then flowing here, right? So you want to take actually estimate the output of this terminal, which is the current leaving terminal of these resistances, right? And this will be the current leaving terminal of the combination of these three resistances, right? Suppose you have make this resistance an equivalent, you have find the equivalent resistance of these three by taking the parallel combination, right? So this would be only one resistance, right? And then, so it means the current is GMVGS multiply by the overall resistance R0 RD RL parallel combination of these three things. Why minus sign? Because this is the current leaving terminal, right? So this is your output, this is VGS, and VGS is equal to V in. When you put V in here, put it down, this is your gain, right? AV. AV or AV not? It's AV because you have considered RL. If you remove RL, then it is AV not, right? And now if you put VGS is equal to VI and then VI is equal to V signal RG divided by RG plus R signal, then you introduce the V signal, and then when you put the V signal down, you actually find the GV. Please do it yourself. Listen to my video, this audio again, and then write it down and check whether all these things are almost similar with the BJT, right? So GV and GV naught, everything you can find out. Okay, so what would be the relation of GV? V out by V signal, right, is equal to minus GM RG divided by RG plus R signal into what? I already said GM, right? If not, then take GM, and then RD parallel to RL parallel to R naught. GV is minus RG divided by RG plus R signal, GM RD RL R naught RL parallel. This is GV. Then we have common source amplifier with source resistance, right? Even if you have more resistances, but at least one of them is available, is not bypassed. Or if you have only one resistance which is not bypassed, you would be having a voltage here, right? If you have having dual supply, otherwise would be grounded. So anyway, this would be your circuit, and if you want to apply direct everything, you can do it here, right? They did it, but I'm not going to tell you this. Please follow the same thing, just replace this with its model and attach other things. How to replace this one? Because we have a source resistance, it is better to take T model instead of pi model. Okay, so replace this with pi model. Here is drain, here it's gate, here it's source, right? So, and this is the model I, or we can say GM VGS, right? And this would be what? 1 by GM, and the voltage across this resistor will be VGS. Okay, so, and again, as I told you that with this VGS across this resistance, you have a current I, and that current I is the same, right? So it's up to you. You take the product of this to put it here, or you find the ratio of this thing to find I, and then I here, same thing. Okay, so then attach the things as source. We have a source resistance, other things are bypassed, so it's not available in the AC circuit. If they're in T model, you are recommended previously that you don't need to take the R0, the early effect resistance, and then just put RD as ground and RL as ground, right? Because this TC will not be appearing in the AC equivalent circuit. At the gate, you have a RG to ground, and you have a practical source having R signal as its output resistance, right? So R naught is neglected. Okay, now what to do? You have to find, for example, AV. So this is your V in. So from here to here, it's your AV, right? So what to do? As I did previously, it's better to make relations as much as possible as you can, right? For example, I can write equation of this one, right? V out is equal to RD parallel to V out is equal to, what is this, I into RD parallel to RL with minus sign because this I is leaving. So minus I V RD parallel to RL, or I is equal to GMVGS, right? So minus GMVGS RD parallel to RL. This would be the relation of V naught, right? Now if what we do with the VGS or I, then we can bring a VI there to get the formula for AV, and replace that VI with V signal to get a formula of GV. Okay, so let me tell you this. What would be your VI? VI would be equal to what? Rn divided by Rn plus R signal into V signal. And what is Rn? If you look inside, Rn is what? Rg, because there is no current flowing into. Although it is looking that you have a resistor between gate and source, but remember, even if you are taking T model, it's not showing here explicitly, but you know there is no IG. Gate is insulated in BJT, in MOSFET, right? So you are having your Rn is Rg, right? But whatever is the signal Vi you have from this gate to ground is appearing from gate to ground, right? And it is appearing here. So it means Vi is from here to here. Then what about the voltage across this resistance? It's simple voltage divider wise. This resistor divided by this resistor plus this resistor into Vi will be your VGS, right? Okay, and then you have this thing. Now if you want to put, you are having GM VGS relation here. If you want to put VGS, take here, right? VGS is 1 upon GM in divide by 1 upon GM plus RS whole multiply by VI. So you can bring VI here, put it down, find AV, and then again if you want to calculate the GV, as you replace VGS with its formula with the VI, replace VI again with its formula with V signal, right? And then find the GV. GV would be found to be RG divided by RG plus R signal into RD per RL divided by 1 by GM plus RL RS. Where is GM here in the numerator? It's actually combined and common out or cancel out someone with this 1 upon GM here, right? Okay, we would be having a 1 upon GM here, and GM for the V out, that would be cancelled out. Okay, so this is all about common source amplifier with RS. Please rewind this video again and again and write the relation as I speak. Okay, you will see it is not difficult. But if you have any problem, please contact me. At the canvas, you can start a discussion panel, and I would be there to answer you. You can contact me by email or by WhatsApp. But I rarely use WhatsApp. I rarely becomes online on WhatsApp if I have something to share or something uh, to meet someone officially, right? So thank you very much.